Hey, what we're looking at today for our notes is solving absolute value inequalities. Now, we talked earlier about solving absolute value equations, and we had 5 steps. We're going to revisit those 5 steps with a few changes in them, okay? So our first step is still the same. We isolate our absolute value. Step 2, instead of just checking for no solution, we're going to check for negatives. Because when we're talking about inequalities, there is a difference. And we're actually going to look at that right now. So our first example, we have 1/2 absolute value of 3 plus x plus 7 less than or equal to 6. So step 1, I need to isolate the absolute value. So I subtract 7 from both sides. And I've got 1/2 absolute value of 3 plus x is less than or equal to -1. I need to multiply both sides by 2 to get rid of this 1/2. So I've got the absolute value of 3 plus x is less than or equal to -2. Now, when I go to step 2 and I check for negatives, oh, look, here I have a negative, okay? So I know I'm gonna stop at this point, but what I'm gonna say is dependent on what inequality I have here. If I have absolute value is less than a negative number, remember absolute value, distance from 0, I cannot have a distance that is negative, therefore I cannot have a distance that is less than a negative number. This is no solution. Okay, looking at example 2, where we have the absolute value of 1 minus 5x plus 9 is greater than 4. Isolating first, so I have the absolute value of 1 minus 5x is greater than -5. When I go to check, this is a negative number, so I'm going to stop here, and I need to pay attention to the inequality. This is now saying I need this absolute value to be greater than a negative number. Well, all non-negative numbers are greater than negative numbers. So it doesn't matter what x is. X can be all real numbers. Okay, so when we are checking for negatives, we have 2 cases that we're dealing with. If our absolute value is less than a negative number, then we have no solution. If we have our absolute value is greater than a negative number, then x can be anything. It can be all real numbers. Okay. So as we continue on, if we check and it's not a negative, we would move on to step 3. Before, step 3 was we write 2 equations, one positive, one negative, specifically writing 2 OR equations. This time, we have different possibilities. We're still going to write 2 equations, but there are 2, I'm going to call them GOLA equations. Still one that's positive and one that is negative. So the big question is, what is GOLA? Well, GOLA depends on the inequality we're dealing with. If it is a greater than, then we will use the word or. If our inequality is a less than inequality, we will use the word and between the 2 of them. And we'll look at what the difference is on that when we look at examples 3 and 4. Okay. 4th step is the same as our previous 4th step. We solve each. And our fifth step, what we're going to do here, we don't have to check for extraneous solutions. Excuse me, I'm sorry. We don't have to check for extraneous solutions, but what we do have to do for us, we're going to convert our answer into interval notation. Okay, so example 3, first step, I still need to isolate the absolute value. So I add 4 to both sides. I've got the absolute value of 3x plus 6 is greater than or equal to 12. Those absolute value bars have been isolated. I don't care what stuff is inside of there, it's just that's all that's left on that side. I check, this does not equal a negative, so I'm good to carry on. I write my 2 equations. I am basing it off of this isolated inequality, the absolute value being isolated, as to tell me what the equations are that I'm writing and whether it's greater than, less than, to be using or and. So I take exactly what is in there, 3x plus 6 greater than or equal to 12. Here, it is greater than, so it is or. When I write my negative equation, not only do I make what is on the other side of the inequality negative, I also have to flip the inequality. So instead of it being greater than or equal to, it is now less than or equal to negative 12. Now I solve each of these independently. Here I'm going to subtract 6 from both sides. So 3x is greater than or equal to 6, dividing both sides by 3, and I get x is greater than or equal to 2. Or, when I do here, I subtract 6 from both sides. So I have 3x is less than or equal to negative 18, dividing both sides by 3. I get x is less than or equal to negative 6. Moving to step 5, if it is or, I can treat each of these individually. And so I have x values that are greater than or equal to 2. 2 being the smallest it could be, so that is on the small side, and x being anything bigger than that, meaning it can go up to as high as it wants to infinity. Because of this or equal to, I know that 2 gets a bracket. Here, x is the small side, so I want x's to be small. That means as small as it can get is negative infinity. The largest number I can have this be being negative 6. Infinities always get parentheses, and again, because of that or equal to, this is going to get a bracket. All I need to do now is put it into the correct order and the correct notation for interval notation. So I go low number to high number, so negative infinity to negative 6. Or when we use that, it's the union, when we're talking in interval notation. I have my other one, 2 to infinity. So there we have our solution for this problem. Looking at example 4, again, I need to isolate first. So I subtract 8 from both sides. So I've got negative 3, absolute value of x minus 7 is less than negative 3. I need to divide both sides by negative 3, giving me the absolute value of x minus 7. Remember, when we multiply or divide by a negative number, we have to change our inequality. We have to flip it the other way. So its absolute value of x minus 7 is less than 1. I do my check. 1 is not a negative number. It passes. I move on. I am looking at this equation once it has been isolated to determine GOLA. So my first one, I have x minus 7 less than 1. Because this inequality is a less than, well, less than, we use and. So x minus 7 is less than 1. And x minus 7, I flip the inequality as well as change it to a negative number. Now, when I solve each of these individually, I add 7 to this one, and I get x is less than 8. And when I add 7 to this one, I get x is greater than 6. When we go to put it into our interval notation, and means it needs to be this and at the same time this. We're going to create a sandwich. We want between the two values. So the low number I have is going to go first, with the high number that I have coming second, and I want values between those. This one gets parentheses because it is not or equal to on that. Okay, so our big takeaway here. The first one is when you do step 2 and you're checking for negatives, you have to pay attention to what type of inequality you have. If it is the absolute value is less than a negative number, that is going to be no solutions. If it is absolute value is greater than a negative number, that is going to be all real numbers. Second thing, when we write our GOLA equations, when we write our two equations, okay? If once it's isolated, it was a greater than, you will use or. If once it was isolated, it was less than, you will use and. And when you write the negative equation, not only do you have to make what was on the other side negative, you also have to flip the inequality the other way, okay? Our last one, when we are changing it into interval notation, if it was or, you will have two separate ones separated by the union. If it was and, it is all together as one. If you have questions, please ask your teacher, myself, whoever else you have, and we will get you the help that you need. Thank you.